As technology progresses, AI becomes more routinely a part of people's everyday interactions in the world. From self-checkout machines to generative AI search engines, AI has many offerings to how people pursue solutions in their day-to-day lives. I myself have been using AI-powered copilots to help me with my coding projects. This AI assistant not only understands my chosen coding language, but also plain English text as well. It automatically creates code from my prompts. It's been a massive help for me. These AI-driven coding assistants, they're always there and available. It's like having a senior developer by my side, without the grumpiness. This was my first experience working directly with an AI copilot. And for me, it has reinforced my view that AI is a tool meant to help, not hinder our endeavors. I, like many developers using these assistants, can now focus on creative problem solving and working on harder and more impactful solutions. This synergy empowers myself and other developers to tackle complex projects with confidence, leading to faster innovation and higher quality software. As AI continues to evolve, so does the potential for groundbreaking advancements in the tech industry. I'm all in. Hey there, I'm Graham Class, and this is Technically Speaking, an Intel podcast. The show is dedicated to highlighting the way technology is revolutionizing the way we live, work, and move. In every episode, we'll connect with innovators in areas like artificial intelligence to better understand the human-centered technology they've developed. This has been such an interesting season filled with not only amazing guests, but also mind-blowing technologies that have so much impact on the way we live. In episode 2, developers Rishikesh and Niharika protected farm life from pests using Intel's OpenVINO technology. In episode 5, Joe and Juan showcased their autonomous public transport and its positive impact on the local community of Lake Nona. It's been a real honour to talk and learn from all of our guests. As we've shown throughout this season, AI exists at the intersections of culture, commerce, philosophy, and education. And with that, it is subject to a very critical lens. In this episode, I want to dig a little deeper into the relationship between AI itself and the developers guiding these projects, from development to distribution. Before we get into the virtual nuts and bolts of things, I want to introduce a very special guest. Joining me now is Intel's Vice President of its Data Center AI Solutions Group and General Manager of Data Center AI Solutions Strategy and Product Management, Jeni Barovian. She leads the team responsible for product strategy, product planning, management, and execution of Intel's data center silicon, software, and systems roadmap. Jeni also serves as an ambassador for responsible AI, championing the ethical development of AI technology and ensuring responsible practices in Intel's product development and deployment. I've been really looking forward to this discussion. Welcome to the show, Jeni.
Thanks, Graham. It's great to be here.
We'll just start really about you, and this is a new role for you. Can you tell us a little bit more about the responsibilities you've inherited in this new role? I mean, perhaps start with, what does it mean to be the VP of Data Center AI Solutions Group?
Yeah, so simply put, I lead the strategy and the product portfolio for Intel's data center AI accelerator business. If we look at the compute power in GPUs and accelerators, this is what has really enabled AI to skyrocket. And these products are a really critical growth area in the industry and also for Intel specifically. The silicon and systems that we build, they operate on a multi-year development cycle. So at any point, I could be working on selling products that are already in the market or pathfinding and defining products that are as far as 5 years out. And my day-to-day kind of includes what you might expect about running a business, managing investments, working with our development teams to build our products, developing teams themselves and employees. But by far, the most important thing that I do with our customers is understanding their needs and their goals to build out AI infrastructure that will power the world.
So as part of that data center AI, I have a background in microelectronics, so I'm quite interested in some of the future in terms of the Intel's AI hardware and silicon. Is anything you could tell us a little bit about that?
We definitely are innovating on a broad scale. and a long life cycle. As I mentioned, we're working many years out. And so it's all about learning alongside our customers and our partners in what they're sensing in the market and what they believe needs to be deployed in the future. And this is moving faster than anything I've seen I've been at Intel for over 24 years, and the pace of innovation in AI is tremendous. Most of my time at Intel previously was actually in our networking business. And that's kind of one of the superpowers that I think I bring to this new role. If you look at the needs of deploying at scale AI systems, it really is about massively interconnected processors and accelerators. So the networking is actually just as important as the compute itself. So that's definitely an area of innovation that I'm particularly interested in driving.
Okay. And are there any sort of projects you could give us examples of some of the innovation at Intel?
What I'm really excited about are the products that we're delivering in our accelerator and our GPU Max portfolio, our Gaudi accelerators. These are powering next generation AI infrastructure. And these are products that are available today, but we're working on that innovation for the next generation as well.
That's great. And if you could explain really the critical aspect of this GPU hardware, graphics processing unit, and why is it so important for the AI technology they use, like chatbots and AI assistants? Why is it so critical?
When you look at the unique needs of AI computing by comparison to more traditional general purpose computing, it really is about massive scale. And the types of processing that we're talking about is massively parallel processing. And so that's really what the GPUs bring by comparison to general purpose processors. General purpose processors also deliver a tremendous amount of value in AI computing because very often what's happening is you're serving multiple workloads at the same time. And so what's great about working at a company like Intel is that there's a variety of assets that we bring for all different types of AI infrastructure that customers are seeking to build out, whether we're talking about large-scale deployments in centralized data centers, as well as infrastructure that extends all the way out to the edge, as well as to the client. And so it really is about that continuum of AI compute that really needs to be powered by both this massively parallel graphics processor units, but also by different types of compute depending upon the deployment size and the use case.
Okay. And we've already discussed in previous episodes on this show some pretty excellent and really interesting AI deployments using Intel as partners. We also talked a little bit about the ethical and responsible nature of developers when they're creating these sorts of systems. What steps are Intel taking to keep these sorts of AI implementations responsible and secure?
Yeah, it's really important as we innovate and deploy AI technology that we look at the positive outcomes that we're trying to create. So this really is about creating positive global change, about empowering people with all kinds of new tools, and really improving everyone's lives around the planet. So those are the positive outcomes that we can create, but we also need to make sure that we balance that with a full approach to lower the risks and also optimize the benefits. So it's about managing both sides of the equation. So Intel has a tremendous amount of work underway in responsible AI. We've been working on this for several years, and this initiative that we have has really evolved to include very structured and rigorous and multidisciplinary processes to advance AI technology responsibly, all the way from, that entire product development lifecycle that I was talking about, from development through deployment. And we have a whole framework at Intel focused on global human rights principles. And so it maps very well to that. We're looking at this really from a multidisciplinary approach. We have a responsible AI advisory council that reviews these goals throughout the life cycle of an AI project. And we look at potential ethical risks within these projects and actively mitigate those risks as early as possible. And really our goal is to actively manage it, but also be transparent about our position and our practices so that we can really address and advance solutions for shared challenges across the industry so that we're not only just improving our own products, but we're improving what's happening across the industry as well. And so we also contribute to various standards and methods at the national level, the international level. There are organizations like the Business Roundtable on Human Rights and AI, Global Business Initiative on Human Rights, the Partnership on AI. And so this is really an opportunity for us to come together with our peers to establish these parameters across ethical and moral and privacy standards so that we can build thriving businesses and innovate really exciting technology, but do so in a responsible way.
Our audience may have heard about the various open source or closed source AI models. I'd like to get your thoughts about Intel's approach to this perennial open versus closed source approach to development.
Yeah, this is a mission that's really essential to Intel. We look at this open approach and open ecosystem priority as essential to lowering barriers to entry and unlocking AI innovation for developers and for customers. And we're really focused on accelerating an open AI software ecosystem specifically that is needed to break down proprietary walled gardens and closed approaches. We really believe that open ecosystems are more powerful than closed ecosystems. They drive a higher level of innovation and they focus on democratizing computing. And we certainly have a long history as a company in this area. And it's been true for many years in other areas of computing. And it's definitely true for AI as well. We saw the industry move from centralized computing to decentralized computing and back to centralized computing with the cloud. And we believe that the pendulum of computing's next swing to the edge is now also underway. I talked about that end-to-end AI deployment across the entire spectrum. And so as we look at all these different areas, we have a proven track record of working with open ecosystems, building open ecosystems, partnering with software vendors and developers to scale technologies. And we're definitely committed to continuing this legacy with AI. And we really believe that to realize the full benefits that we've been talking about and focusing on delivering AI everywhere, it truly means AI everywhere to everyone, to developers, to all your devices, to all types of compute, to all of your use cases and business models. And it's an open ecosystem and open source software that are foundational to ensuring that this can be fully accelerated.
You talked a little bit as well about some of the tools that Intel are supporting. We've had earlier episodes leveraging the OpenVINO platform. And there's also like some other AI software tools, OneAPI, and also support for the open source projects like PyTorch and Hugging Face. Perhaps you could explain to us a little bit about these tools and why they're so useful for developers.
Yeah, I'll talk about a few of these because it really is about unleashing the power of developers to realize the power of AI technology. We're creating this foundation in our silicon and our systems and our software, but it's really about empowering developers. So if we look at a few of these, I'm going to start a little bit actually with OneAPI and looking close to the hardware. We have a OneAPI programming model that's really the software foundation of our overall AI strategy. So this is really about providing a standard programming model that allows these developers to get value across multiple different hardware architectures. I talked before about the fact that you've got heterogeneous hardware architectures depending upon the type of AI solution that you're developing and deploying. And so being able to access the value of these different hardware types from one set of source code is really crucial. It's a really critical aspect of our goal to democratize AI and allow developers to access all of this to build and deploy AI solutions everywhere. So if we look at the different stages of AI development in terms of both development of the model and treatment of the data throughout the entire life cycle, one of the really fastest growing areas of AI development is in fine tuning. So there's so many models out there. You mentioned Hugging Face, right? That's a massive community for models. And it's just, again, the pace of innovation there is absolutely huge. And so if you choose a pre-trained model, that's a great way to get a head start on a solution that you're trying to build and ultimately means faster time to insights for your enterprise. And so you can take a pre-trained model and then it's really, okay, what do you do to get it ready for what you're trying to do? So this aspect of fine tuning it, bringing in your own data and making sure that it's ready for your application, it's a really set of crucial steps to accelerate that development and deployment lifecycle. Then once you do that fine tuning, right, you've got your data, you've fine tuned your model. Now it's about, okay, how do I deploy that and get that ready for inferencing? So obviously you got to worry not only about the deployment, but updates across the various locations where you've deployed the model.
Yep.
And this is really where OpenVINO comes in, right? The OpenVINO toolkit can really be a good asset in deploying all sorts of AI technology, but specifically vision and natural language processing models across a variety of different types of deployment targets. And if we look maybe a little bit more broadly across other tools, we've got libraries that enable the AI ecosystem across a variety of toolkits and optimized software and libraries and frameworks, particularly ensuring that the popular frameworks are optimized for what developers are seeking. So what this is important for is enabling orders of magnitude performance improvements and increasing productivity for developers across AI workloads. So if we look across all of these different tools, whether it's, the libraries, OneAPI, OpenVINO, optimizations for these frameworks, our goal is really to give developers the openness and the choice that they need with all of the hardware architectures that they're using, and making them easy to program and easy to access the power of that underlying hardware, and really ideally with one code base across many different architectures.
Yeah. I guess previously there weren't traditionally AI engineers or AI developers. And I think one of the powers of the tools that you were just talking about is that you can be a developer, but not specifically an AI developer. And this will give you a leg up to actually start innovating and start experimenting with all of these models.
Yeah, I think that's a really good point. And really, the developer landscape is changing, as you said. When you look at the entire population of developers that we are seeking to reach, something like 80% of developers operate at the framework level and above. So
Yeah, that's
meeting developers where they are is absolutely crucial to our strategy. And so there are those who will operate at that level and never directly access the hardware, but they need to be able to unleash the power of that hardware for the applications that they're building. And so ensuring that no matter where they are, we have the tools in order to empower them to achieve those goals. That's really our objective.
Yeah, and this leads on to the Intel Developer Cloud initiative that has Intel's latest hardware and software for testing and building. Can you explain a little bit about that and the importance for the developer community?
Yeah, I mentioned getting access to all of that great hardware, right? So developers really, they want the most performant solutions. And for that, they need to have access to the latest and greatest AI platforms. And so that's really what Intel Developer Cloud provides. It's access to current platforms, and it's also access to new and future platforms that may be available prior to their launch for initial development and testing. And so this is something that we've been building over time, and we've expanded it to provide developers and partners early and efficient access to a variety of Intel products and technologies, in many cases from a few months all the way up to a year in advance of full product availability. And what's important about cloud-based development is it's the best way to get access to clusters of systems for at-scale development and testing. I talked a little bit before about the fact that, when you look at large-scale AI deployments, it's not just about a single node. It's not just about a single processor. It really is about clusters and large-scale development. And so being able to access clusters in a cloud-based environment is really important for developers to be able to, not just do that initial development and testing, but actually ultimately be able to test it at scale. And so if we look specifically at some of the products that are available in Intel Developer Cloud, it includes our Xeon processors, so 4th gen and 5th gen Intel Xeon Scalable processors. It includes our Xeon Max series, also our GPU Max series processors, our Xeon D processors, our Gaudi accelerators, and our GPU Flex series. So really what we're trying to do is provide developers with that full breadth of solutions that meet the needs of AI solutions that they're seeking to develop across that entire spectrum. There was a actually really great example that I heard from our peers in Intel Developer Cloud about a professor at Kansas State University who was specifically working on COVID research. And so he was using machine learning techniques enabled by OneAPI on Intel Developer Cloud. And his goal was to focus initially on drug candidates for clinical studies and experimental drugs. And he was able to, through access to Intel Developer Cloud, use that compute power that was available in that deployment in order to drive breakthroughs in his medical research. And so, it definitely is about our direct customers to the technology and giving them access to our latest generation products, but it's also about users of technology across the entire spectrum, including key partners in research driving innovation in AI.
You have a really interesting project with the Argonne National Laboratory. Can you tell us a little bit about that?
Yeah, this is a multi-year collaboration, and I'm really excited actually about the progress we've made. And I'd love to talk about some of our innovation there. So, Argonne National Lab is a leading research center in the US, and it's really focused on being on the forefront of our nation's efforts to deliver exascale computing capabilities to advance science. And they've got a specific project around Gen AI, which is a collaboration between Argonne and Intel and a number of other partners to enable the power of Gen AI to create state-of-the-art AI models specifically targeted at science. So these are models that are being trained on scientific texts and code and science data sets from a whole bunch of different diverse scientific domains. And so if we look at using these foundational technologies, and we're unleashing the power of the hardware, but focused on technologies called Megatron, and we're using the deep speed frameworks, this Gen AI product is going to service a number of different scientific disciplines. If you look across biology and cancer research and climate science, cosmology, material science, the list really goes on and on when you talk about a machine of this size. So we really have an opportunity to work on really hard, large-scale problems. And if we look at the types of problems that are slated for initial deployment on the Aurora supercomputer, it's areas like developing safe and clean fusion reactors, neuroscience research, understanding the dark universe, designing more fuel-efficient aircraft. These are problems that require an intensive amount of compute and an intensive amount of data. Yeah. And so it really is about a level of scale of the number of parameters that are supported by the model far in excess of any computing that's deployed today. And so it was really important for us to partner with Aurora to prove out the ability of this technology to be deployed at scale. And so what we announced last month at the Supercomputing 23 conference in partnership with Argonne was starting with a 1 trillion parameter GPT-3 large language model on the Aurora supercomputer. And the way that we were able to support that very large number of parameters was to be able to leverage the underlying capabilities of our Intel Max series GPUs. As I mentioned before, those GPUs are essential to driving massively parallel compute to be able to compute that tremendously large model and large number of parameters. But we didn't stop there. It was crucial to prove out the ability to handle 1 trillion parameters, which we did on 64 nodes, which was far fewer than typically would be required, but extend beyond that, scale beyond that. So we ran 4 instances on 256 nodes, which demonstrated the ability to pave the path to scale to training trillions of parameter models with trillions of tokens on more than 10,000 nodes. That's really our ultimate goal. So when you think about workloads that fall in these different domains that I was talking about before. So things like modeling complicated chemical processes in drug design or enabling efficient screening of massive chemical data sets to focus on innovation in molecular science. This is the performance necessary to tackle these massive problems and some of the most important questions that are facing science, but ultimately really humanity today. And so it's really this work that we're driving between Intel and Argonne National Laboratory, in which we've already started to prove that we've got these tangible examples of how people can really expect unprecedented levels of innovation and groundbreaking research focused on this foundation of exascale computing.
All right, so we talked about the large models.
Yeah.
Maybe talk a little bit about some of the smaller AI models. What are your thoughts on that and how it's currently being used?
The airtime really is on a lot of the large models, isn't it? And
Yes.
certainly there's a tremendous amount of innovation that's happening there, but they're very costly to deploy, train, and operate. And it's got tremendous, potential and promise from everyone who is developing them and ultimately using them. But we need to make sure we solve the problems of access and cost as well. And so really what we want to look at also optimizing is not just those large models, but also the other end of the spectrum, as you said. And this is where we see even more action, more new developments, more new use cases. That's why these communities that are driving model innovation, Hugging Face is a great example, is really accelerating this end of the spectrum. And really smaller models are what enable a much larger number of developers to make AI come to life, where they're focused on developing new applications, where companies are extracting extracting value by building new business models around AI deployments. And one of the fastest growing portions of just the overall AI development and data flow is looking at deployment specifically. And one of the most interesting challenges in driving this wider range of deployments is making these models smaller, but still delivering the same level of accuracy. And so you start to look at deployment areas like smartphones and smart home devices to surveillance and industrial IoT, sports and entertainment domains, manufacturing, transportation. There's so many different domains. And this is an area that I'm particularly really excited about. I talked about, how I came from the networking business at Intel and also focused a great deal on edge computing. And these are areas where we're not talking about at scale AI computing, but we are absolutely talking about needing to unleash the power of AI. And so these are areas where those smaller AI models are essential. If we just look at one area in transportation, airlines are exploring the use of AI co-pilots to help do things like suggest a better altitude, to prevent creating contrails, to, meet climate and sustainability objectives. If we look in the entertainment industry, game developers are using smaller AI models that are based on gestures and conversation data, as gamers interact to build more lifelike game characters. So the opportunities are really endless as we look across both business use cases as well as consumer use cases. And you can really see in these examples where the needs of those small models need to continue to grow and where we really need to focus on driving innovation at that end of the spectrum as well.
Do you think in the future, you might have these AI smaller models like on everyone's desktop sort of thing?
For sure. We're already there. So, we talk a lot about ChatGPT. Everyone likes to go into their browser and innovate and leverage the power of that technology by using that very large model that exists in the cloud. But we also have local GPT applications where you can use the power of your local compute, even your PC. And of course, AI is driving a number of innovations around the AI PC and ensuring that you can unleash the power of AI locally within your office at your location. And as I mentioned, with edge computing, even devices that have far less horsepower than your local PC.
Oh, I'm looking forward to it. Also, there's another partnership that you have with Mila, which is the Quebec Artificial Intelligence Institute.
Yes.
It has the largest concentration of world-class deep learning academic researchers. And they have a mission of inspiring innovation and progress in AI for the benefit of humanity. Can you talk a little bit about the work Intel's done with them?
Yeah, absolutely. This is really under that mission that we have of advancing AI everywhere. And we're really grateful for the collaborations that we have to advance this across many different areas. And it really requires partners across the value chain. So we've talked about Hugging Face a couple times. Hugging Face, for those who don't know, develop tools for building applications using machine learning. And it really exists as the single largest model hub for transformers and large language models and all types of models. And together, we're partnering with Hugging Face here at Intel to build optimization tools to accelerate training and inference with transformers. And so what's exciting about these partnerships is when we really see them in action and we see customers and partners leveraging these Intel optimizations and tools to really advance AI and deliver on this goal of AI everywhere. And our strategic research and collaboration with Mila is really going to speed the research and development of advanced AI to solve some of the world's most critical and challenging issues. As part of the specific commitment, more than 20 researchers between Intel and Mila are planning to focus on developing advanced AI techniques to tackle areas like climate change and material discovery, and also molecular science, so molecular drivers of diseases and drug recovery. And if we look specifically in that area, biology in particular is just a tremendously exciting frontier in natural sciences. And so you can imagine, the results that could be created. You've got the opportunity to truly usher in the era of precision medicine, where we have an opportunity to learn from all of the massive data that exists to bring benefit certainly to humanity, but specifically to individuals. And so it's just one area of focus, but the potential, as you might imagine, is huge. And this is where Intel and Mila are really leaning into evolving that relationship and really focusing on this opportunity for technology to really benefit humanity.
We've seen that AI has been used already for customer service and communication. And we've also talked about the ethical and responsible use of AI. What are some of the challenges that business face when trying to implement an AI solution in respect to trying to keep it responsible?
Yeah, we've already talked about the fact that as we look at the promise of AI, it definitely is not one size fits all. And there's a tremendous amount of complexity. And it doesn't just come from, how do you manage the data? How do you drive data science innovation? There's also technology complexity that we have to work through and help our customers work through in order to really derive that business benefit. And so for us, it's really about the innovation that we drive, but also the ecosystem. So the data and AI software ecosystems and the hardware ecosystems that are available across that entire spectrum of AI solutions that I was talking about, from cloud and large scale centralized deployments to edge to client. There's so many different ways that this needs to be implemented, and the complexity of that technology needs to be managed. As AI gets widely adopted and deployed and consumption increases, we also need to ensure that it's accessible and cost effective. I talked earlier about the massive costs associated with training models and with driving inference on large scale models. And so this definitely is a top goal for us as we look at helping our customers derive as much business value as they can. So you've got to look at the entire spectrum. How do you bring data into the model? How do you keep track of your models and model versions? How do you drive updates? How do you do training? And of course, fine tuning, like we talked about before, but also retraining. And then how do you look at the different deployment options and then ultimately integrate them into business applications? And really, a lot of existing business applications, there's a legacy code base there.
Yep,
There
right.
is legacy infrastructure that isn't going to go away. And so you have to manage all of that together. And so our goal is really to offer a complete portfolio of AI hardware and software and tools optimized for any needs, and then help them choose the best solution that meets their needs.
Yeah, and kind of leads me to, we're talking about business in general. My family has a history in small businesses.
Yeah.
And I'm particularly interested to know your thoughts on how maybe the smaller end of town can leverage some of this really cool stuff that's going on.
Yeah. What's exciting about it is that even a small business can take advantage of AI technology deployed locally, but also take advantage of AI technology that exists in large scale deployments as well, that are interconnected through cloud-based deployments. So how do we do this? It really is about taking these hardware and these software tools, provided by Intel, provided by our ecosystem, to enable organizations to accelerate performance and really expedite the results for the goals and the KPIs that they're driving, and really ultimately improve their return on investment, and then just turn it into a learning cycle. Drive that AI development and workflow process, but really learn from that and ultimately drive improvements and streamline development for expanded use cases from there. So it's kind of starting in one domain, but then having potential to expand to other areas as well. If you look at an area like healthcare, this can mean accelerating research and patient outcomes with more accurate analysis of areas like medical imaging. If you look at manufacturing, there's large-scale manufacturing and very small-scale manufacturing, right? But all of them have potential to transform data into insights that can improve performance and minimize downtime and improve safety. Those are of concern of a manufacturing site of any size. Retail's a huge area of focus for small business. No matter the size of the retail institution, they're all very interested in wanting to understand their customers better. So you look at areas like inventory management and loss management and loss control and other key metrics. And so taking the data that you have, gathering even more data, and then using the power of AI to drive those business outcomes is essential. Really, it just starts with understanding what the business needs and challenges are before you ever even talk about the technology.
Yes, that's right.
What are the business needs and the challenges? And then partnering with Intel, partnering with our customers in the value chain in identifying the best AI solutions and outcome. And really, for us, we're just trying to accelerate the time to market for those AI-enabled offerings across every industry to maximize business value for both the large enterprises as well as the small businesses.
In terms of improving business productivity, are there any specific examples of how AI technologies at Intel actually achieve some really significant gains?
Yeah, so for sure, I'd love to share a couple examples. So we did talk a little bit before about healthcare and sciences. So I want to kind of shift gears into a little area. Oh, shift gears. I was going to talk about manufacturing. So I guess that's a little bit of a pun. So a major beverage bottler in Asia turned to Intel and AO2 in 2022 to build a framework that could transform a variety of manufacturing and safety inspection processors at a number of their regional factories. And what they really hoped to do was to take the safety monitoring process into the digital age through machine vision and AI, but still integrate that into their core IT systems. I talked a little bit before about the fact that you need to integrate into legacy IT systems, legacy software. So with Intel and AO2 on board, the company embarked on a whole safety transformation project. And this was focused on revamping security processes at these factories, really all the way across China. So this company, they were really focused on taking humans out of the safety monitoring loop wherever possible to improve results. And they had some tremendous results. They were able to reduce manual workloads by 80%. They were able to trim the costs that were related to their health and safety and environmental compliance by 60%. They were able to boost the violation detection rate from less than 20% to 90%, which varied from a 4 to 5x improvement in time saved as well. And they also reduced safety violations by 35%. So this is through the use of AI technologies. It's computer vision. And so it's taking inputs from multiple different cameras on the factory floor and being able to detect different patterns like worker movement or worker machine interaction, or being able to enforce safety boundaries around equipment. You achieve tremendously better results for the business's bottom line, but also safety for the people who were involved in the factory. And so really almost overnight, they witnessed enormous benefits that totally altered how they approach monitoring and inspection. And they put this advanced solution in place, and it really accommodated the very complex and very intense automation requirements that they were seeking to build. Let me shift gears a little bit again and talk about the entertainment industry. So if we look at the broadcasting industry, it's really benefited already enormously from digital transformation. But at the same time, the hardware and the networking infrastructure sometimes really hasn't kept pace with that level of change. And so many businesses still rely on, cumbersome and sometimes dedicated hardware that can be very expensive. And very often they're actually locked into specific brands and equipment. And so if you think about the massive opportunity associated with very large entertainment events. So eyes around the world tuning into Formula One racing or World Cup or next year's Summer Olympics in Paris. This can translate into a lot of great business outcomes in advertising and other revenue dollars for broadcasters, but viewers really want a seamless experience as well. And so these broadcasters depend upon a number of different vendors across, so many different events and locations, and they have to deliver on those performance needs. They have to deliver on performance and low latency and real-time visibility and monitoring and a really rich viewing experience. It's not just about viewing the event. It's about viewing additional data associated with the event and real-time analytics and real-time commentary. And they really want a solution that is powerful and agile and easy to deploy, that doesn't sacrifice performance, doesn't sacrifice quality. And also they need to be able to, from a technology standpoint, leverage on-site infrastructure as well as the cloud and do that seamlessly between the different locations. So this is where we've been able to innovate alongside our partners. And in this case, the example I want to talk about is Fox Sports. Fox Sports used tag video systems, monitoring and visualization platform, which ran on Xeon CPUs. They use this in all of their control rooms and their operations to show 64 of the soccer matches in the 2022 FIFA World Cup in Qatar across the US and also on Fox and FS1 channels. And these matches were being live streamed also on the Fox Sports app. And they also had to be, of course, available on demand for replays later. So the system had to be able to monitor the integrity of over 1,200 sources and drive over 150 displays. So how did they tackle this massive challenge? They deployed deployed this really first of its kind live production system called a FlyPack. This system includes a full control room, 40 tech core racks, 10 venue racks, and these equipment racks, they were built around Intel Xeon processors, and they can actually be flown in a plane. They can be flown via 747 from venue to venue instead of having to travel aboard container ships. So the FlyPack arrives, it's fully pre-wired, and it can be powered up and ready to go within 6 hours. And they report that it's allowed them to shave weeks off of their setup time. So it really is about improving interoperability and portability and agility. And really, it's transforming and revolutionizing how live production is done. And so, Fox Sports really also has been able to change and add to the system as their needs evolve. So a lot of really exciting innovation in that combination of harnessing the power of compute and edge applications and AI, and really impacting a number of different industries.
All right. And just to wrap up, I'd really like to get your thoughts on the future of the data center and AI technologies at Intel, and what's your number one area of excitement for the future?
Yeah, I'm relatively new to this role. And in the short amount of time that I have spent in this role, I have seen growth like nothing I've ever experienced. Right. The pace of innovation in terms of the solutions that are being deployed, but the pace really incumbent upon Intel for innovating technology to empower those solutions is massive. It's truly undeniable that AI is changing the way that we're living our lives, the way that we're working, the way that we're driving business transformation. And I'm really an optimist when it comes to the power of AI. My goal professionally is to innovate and deliver the technology and the products that really enable AI to help humanity become the best version of itself. There are so many big problems that we have to solve. We've talked about a couple of them today. When you look at climate, to discoveries in science, to driving social change, AI can be an engine to create solutions for all of these and more. So it's really exciting to be part of the technology innovator who, of course, is, one of the most significant in the history of computing, but really on this precipice of AI innovation and really driving this next phase of at-scale compute deployments and AI innovation to power those deployments and create solutions for the future.
I definitely share your optimism. Thanks very much, Jeni. That was awesome.
Thanks, Graham. It was really great to talk to you.
Thanks very much to my guest, Jeni Barovian, for joining me on the season finale of Technically Speaking, an Intel podcast. This episode illustrated the significant advancements and contributions made in the field of open source AI worldwide. As a developer actively engaged in AI projects, I deeply appreciate the support provided by corporations like Intel, both financially and in terms of fostering open source developer communities. Jeni provided an extensive discussion on the topic of responsible AI, emphasizing the necessity for companies to ensure their AI implementations adhere to ethical principles. In my view, it is imperative for businesses to explore responsible AI initiatives and establish a set of standards that can be clearly understood and implemented by the executives, managers, employees, and contractors. It is essential for employers to encourage their workforce to voice concerns if they perceive any AI projects to be in conflict with their personal moral and ethical standards. Engaging in open and candid discussions with our peers is crucial in developing technologies that benefit humanity as a whole. The development of large-scale AI models and supercomputers by companies like Intel may appear daunting and seemingly unattainable for smaller enterprises. However, it's important to remember that technological advancements often start with significant investments by pioneers in the field. The first computers, costing millions of dollars and possessing only a fraction of the power of a modern calculator, were necessary stepping stones that led to the explosion of personal computing and the advent of mobile devices. In the same vein, the cost of deploying and operating AI technology is expected to decrease over time, enabling businesses of all sizes to utilize AI in ways that positively impact their employees and customers. I'm excited to see all the cool things that people come up with to improve our lives. Thanks for following along for the first season of Technically Speaking, an Intel podcast. To learn more about how Intel is revolutionizing the future of AI, check out intel.com/stories. If you enjoyed this season, please stay subscribed to get updates about Season 2. which will be coming out in spring of 2024. Thanks again for listening. Technically Speaking was produced by Ruby Studios from iHeartRadio in partnership with Intel and hosted by me, Graham Class. Our executive producer is Molly Sosha, our EP of post-production is James Foster, and our supervising producer is Nakia Swinton. This episode was edited by Ciara Spreen and written by Tyree Rush.